Hello, let me introduce you to the Fluid Corpus Manipulation Toolbox, dedicated to programmatic sound bank mining towards a musicking research community around these questions. But first, let's start with a quick demo. Here, one could experiment with simple voice control of a patch using a classifier to recognize the nearest vowels from a training dataset. Here, one could make a corpus of states of a Corpus synth, then assign them to a controller space, then fit the two datasets and control one space with the other. Or make a dataset of the descriptor space of the sound output with a few states or 10,000 states, regress, and then do audio-driven resynthesis. Or let's say that one would like to explore in a bespoke jitter navigator the impact of reducing a dataset of high-dimension descriptors in 3D. One can come to the forum and share their patch in progress like Rodrigo and Balint did. So what is the Fluid Corpus Manipulation ecosystem? First, it is a toolbox dedicated to programmatic data mining focused on sound banks, cross-platform, within Max SuperCollider NPD over their 3 supported OSs, with careful interface design to enable even more bridges of ideas, of processes, of code, and of data, however small or big, however convergent or divergent, all of this in tandem with supporting resources and community to share, discuss, exchange, and challenge each other. The bigger question is why place a machine in this loop of heuristic of musicking, and where to place the machine and how to use the machine in the dynamic system of making sense of the material we have as we make music and vice versa. The challenges were how to get the discussion going while tackling musician-sized sound collections, which are getting bigger, in a programmatical manner within the mastered creative coding environments and within the workflow of various sizes as an intrinsic part of the musicking process. In other words, how to make data-driven musicking using big data tools on small data sets. But why would one want to do this? In this loop, musicking challenges the assumptions at all steps of this process and then is challenged back by the results given by the computer. For instance, how one goes from a bunch of sample to a corpus, how one describes the sounds in time or the famous machine listening conundrum, how one uses proximity as similarity. Does this make sense? How does the computer find strands and patterns in the data as described? And how hybridizing is made convincing, or what other quality criteria is used. And changing one aspect of each of them influences all the others and the musical thinking behind. A good metaphor of this system is the double pendulum, where changing one aspect of one element in the system changes the behavior of the whole system radically. To make sure the design process was successful, we commissioned alpha users early in the loop to make sure that our software design criteria were really yielding an open and modular interface that was consistent across all the supported creative coding environments, yet felt native and integrated within musicking workflows. Now, we know we're not the first one to do that. Who else is doing this? But we take the view that there is an ecosystem out there of available software and their respective communities of practice, and if we are open enough, can be sharing challenging questions and various workflows and assumptions and priorities and knowledge and know-how. Some of them will be more open-ended, some of them will be more focused on specific tasks, and some of them on specific workflows. We do a review in the paper of the various software already available and how they differ and complement our offering. We also reflect on the various enabled workflows by the toolset in that process, by the three authors' productions, but also by the first set of commissioners. Alex Harker using real-time timbral classifier of oboe multiphonics, Alice Eldridge using neural net to dialogue with her feedback cello, Hans Tuchku using NMF as a polyphonic piano tracker, Richard Devine using NMF and HPSS to expand his modular sound bank, and Sam Pluta using a neural net to navigate a chaos synth. In effect, we've seen trends in the various use and abuse from these composers, as well as from the online community, that we could classify under a bespoke corpus assembly, dynamic multi-step query, parameter space explorations, and adaptive interface designs. All this material is available on the website, where each musician presents their work in progress and intentions with the toolset. So, what is this interface? Building on the first toolbox we released 2 years ago at the ICMC, where one could slice, decompose, describe, and run statistics on real-time and buffer-based audio, this new edition is based around the concept of a dataset, which is a key value store. And we use buffers, which are very familiar, cross-platform, and accessible into the audio domain, to interface and enter and retrieve material from that dataset. We've also built dictionaries, which are supported in both Creative Coding environment, which we can export and import as JSON as well to enable even more exchanges between our ecosystem and other data mining software out there. We have a curated family of algorithms for pre-processing, searching and querying, supervised machine learning, unsupervised machine learning, and transform audio. Here in the Toolbox overview, you can see the various algorithms to slice audio, to decompose audio, and to analyze it, all curated algorithms that can be run in real time or in buffers. And then we have the dataset framework, which can be filled by buffers and by JSON, and where you have various pre-processing algorithms, normalizing, standardization, various querying and searching via KD3 or SQL type query, or you have supervised machine learning based on KNN and MLP. And on the other side, unsupervised machine learning, the simple PCA and K-means, or the more advanced UMAP algorithm, and each of them come with a help file and documentation, which has example, in this case showing a 3-dimension color space being reduced in 2 dimensions with this powerful algorithm. One could explore the various parameters dynamically and obviously programmatically as part of the musicking process. In this simple example, we can see how one could explore basic vowel recognition through MFCC. Training a basic classifier based on the nearest neighbor found in a dataset. It's very interactive, and it allows people to explore all the various hinges of this process, how one describes, how one deals with time, how many examples are used, what classifier is used, and what these classes are mapped to, in this case, just recognizing them, but what will be their musical impact, having simple, quick prototyping where things could be easily interchanged because of a consistent interface design. There are quite a few examples online showing various workflows where musicians have decided how and where to place things. In this example, we have variations made on simple gestures fed from Reaper in real time, controlling the same synth that we heard previously. The audio is buffered, analyzed with triggers, and entries are made in datasets. When we like the sounds, we define a new point by sending a trigger. Once we have enough points, we can regress between preset space and descriptor space. Reducing the number of dimensions helps the regression to converge faster. Once the neural network is trained, we can feed the audio from Reaper via loopback and control the synth dynamically by the audio feed. Now let's see this in Musicking context. This sound would really benefit from a synth counterpoint. Much better. Let's apply the same process on similar sounds. Trying the same process on different sounds challenges and stimulates my musical thinking and helps me moving the piece forward. Going over this whole process takes longer than this video, but these ideas, as well as many others, are available on the forum, where musicians discuss their priorities, their attempts to try the music, and how their music thinking is influenced by their creative coding and by their programmatic approach to sound as a corpus and their musical question through that lens. Another example of a fluid corpus manipulation research enabled by the toolset is this one, in which various slices are analyzed in 3 sections to describe their spectromorphological contour. We can hear that these synth sounds have got a profile. This profile is then described in 3 dimensions of pitch, loudness, and centroid, in comparison to a more classic spectral description through MFCC. Then, a target sound, in this case a drum loop, will be segmented, and each of the segments will be analyzed in the same way, and then the nearest neighbor of this encoded time series of descriptors will be retrieved and assembled in time. Here we hear the loudness, pitch, timbre reconstruction. And here the standardized MFCC version. This back and forth process between thinking of machine listening in time, coding hypotheses, comparing various ways of thinking about these things, and the clarification of the musical ideas was only possible because of the flexibility built in the system and its ability to incorporate the rest of the musicking workflow. We finished the paper with our next steps. Obviously, now we're in public beta. We have an emerging community online. Obviously, we can grow the toolbox because we have created a C++ framework, which allows us to expand and solidify what we have. And we are developing a platform of supporting learning resources because this is where there is still quite a lot to do for our community of programmatic data miners and thinking of corpus manipulation as an active, creative, open musicking process. If you want to join us, you can download and play. There are help files, documentation, and a growing example folder to explore and get going. You can join us online to discuss wider issue and share your code. Maybe our toolset is not for you or your student or your community yet, maybe because the learning curve is too steep yet, or maybe you're happy with the other software you're using. But I'm pretty sure we share questions and we'd be very happy to hear about how you tackle these questions. If you're C++ savvy, all the code is on GitHub, and we've started to accept pull requests, bug reports, and suggestions for various improvements. Thank you for your listening.